Hello viewers. Today I am going to explain you how to find reactions for a simply supported beam by manually and by using SAP 2000 program. So here is the problem. So this is the simply supported beam. So total length of the beam is 6 meters and it is subjected to point load as well as UDL. So first let me solve this problem manually and later by using SAP 2000 program. See here, the given beam is simply supported beam. So first I will try to draw the free body diagram. So here the reaction is RA. So here the reaction is RB. So total length of the beam is it is 6 meters. So here you have a point load 4 kilonewton at a distance of 1.5 meter from support E. Next, you have another point load 1.5 kilonewton which is at a distance of 1.5 meter from support B. Okay, so this is your point A, B, this is C, D and E. So next I will convert this UDL to point load. So intensity of UDL is 2 kilonewton per meter and it is acting over a distance of 1.5 meter. So conversion of UDL to point load. So 2 into 1.5. So it will be 3 kilonewton. So here the 2 is intensity of UDL and 1.5 is the distance. Okay. So after converting this UDL to point load, you will get 3 kilonewton. So and it will be concentrated at the center. So 1.5 meter means 0.75 meter from this end, 0.75 meter from this end. So let me calculate the reactions by using equilibrium conditions. So first I will use sigma H equals 0. So there is no horizontal forces. So next I will use sigma V equals 0. So my sign convention will be upward forces positive whereas downward forces negative. Okay, so if you observe this free body diagram, so reaction RA plus reaction RB, next minus 4 kilonewton minus 3 kilonewton minus 1.5 equals 0. So reaction RA plus reaction RB, so equals, so if you solve this term you will get 8.5 kilonewton. 8.5 kilonewton. I will call this as equation number 1. So next I will use sigma MA equals 0, which means taking moment of all the forces about point A. So I know the sign convention. Clockwise moments will are considered as positive, whereas anti-clockwise movement are considered as negative. So here, so RA into 0. Next, so 4 kilonewton, it will rotate in clockwise direction about point A. So clockwise movement will be plus. So 4 into 1.5. Okay. Next, this 3 kilonewton. So it will rotate in clockwise direction plus 3 into. So it will be 1.5 plus 0.75. So it is 2.25. Okay. Next, 1.5 kilonewton, it will also rotate in clockwise direction, so plus 1.5 into, so this distance will be 4.5. So from here to here, so this will be 4.5 meter. So next reaction RB, it will rotate in anti-clockwise direction. So RB into 6, which is equal to 0. So here RA is 0. 4 into 1.5, you will get 6, plus 3 into 2.25, you will get 6.75, plus 1.5 into 4.5, you will get 6.75, minus RB into 6 equals 0. So therefore RB into 6 equals, so you will get 19.5. So reaction RB equals 19.5 divided by 6. So you will get a reaction RB as 3.25. 3.25 kilonewton. So once you get the value of RB, so it is easy to calculate RA. Just to substitute RB in this equation. So you know RA plus RB equals 8.5 kilonewton. So you know the value of RB. It is 3.25. So reaction RA equals 8.5 minus 3.25. So reaction RA comes out to be, so 5.25. 5.25 kilonewton. So this is your reaction at point A. So final answers will be reaction RA equals 5.25 kilonewton. Reaction RB equals 3.25 kilonewton. So this is my final answer. So let me verify the same answer by using SAP program. So just I will open the SAP program. Just I will remove this. So you remember the answers. So let me start with the new project. So file, new model. So first you select the units and here beam. So here the number of spans, I will make it as 1, and span length. So you already know length of the beam is 6 meters. So I will remove the restraints here. Okay. So I will close this 3D view. So I will change the background. So I will make it as white background. Okay. So to remove this grid line, so here edit, sorry, view, you just click on this show grid. So it will be removed. So this length of the beam is 6 meter. So you can check by right clicking. So here the length of the beam, it is 6 meters. Okay. So you know the support condition. At point A you have simply supported. So joint, restraints. So this is your simple support. So apply, close. So this is your simple support. Similarly at joint B, assign, joint, restraint, simple support, apply, close. So this is the supports, simple supports. You can view the 3D view. Okay, so this is front view. So next I will assign the loads. So already you know the loads. So 4 kilonewton from 1.5 meter and this 1.5 kilonewton from this end. Okay, so let me apply the loads. So first select this frame, assign frame loads. First I will apply point load. So there are 2 point loads. So first I will make it on 0. So there are 2 point loads. So I will go with absolute distance from end, starting end. So first at a distance of 1.5 meter you have 4 kilonewton. See here, at a distance of 1.5 you have a load 4 kilonewton. Next at a distance of 4.5, so from starting end it will be 4.5, so load will be 1.5. So next your distance will be 4.5 whereas your load will be 1.5. So add to existing loads, apply, close. See here, so you have the loads. So you can increase the font size also. So options, dimension, tolerance. Okay, so this is 4 kilonewton and this will be 1.5 kilonewton. Next, UDL, uniformly distributed load. So let me see the problem. So uniformly distributed load, intensity of UDL is 2 kilonewton per meter and it is acting over a distance of 1.5 meter and it is at a distance of 1.5 meter from left hand support. So this will be 1.5 and this will be 3. See here, assign frame loads distributed. So first I'll make 0. See here, first distance. So if you observe the diagram, first distance, your starting point is 1.5. 1.5. So your intensity of UDL at the starting point it is 2. So it is 2. So next, so your UDL ending point will be here. So with respect to starting end, it is 3 meter. Intensity 2. So 3, intensity 2. Apply, close. See here, this is your UDL. So you can 3D view. 3D view. This is your UDL. So next I will run the analysis. So analyze, set, run analysis. So here there are two load cases. One is dead load and another one is model. So I will first select model. So I will do not run this case. So I will run only for dead load. So select the dead load, run now. So next it will ask to save. So just I will save the file with SAP Beam. So now you can view the reactions. So here it is, reaction RA is 6.23, 4.23. But my manual calculation answers are, so reaction RA, so reaction RA is 5.25, 5.25 kilonewton. So my reaction RB is 3.25 kilonewton. So here there is a difference. So for which I will first unlock the model. So while analyzing the beam, self weight of the beam is to be neglected. So first I will select the beam. So assign frame property modifier. So weight. So I will make this weight as 0. Apply. OK. So let me run now. Yes, see, now I got the correct answers. So this is your reaction RA. So it is 5.25 kilonewton, and this is your reaction RB, 3.25 kilonewton. So the final answers are matching. Okay, so you can view the answer in tabular form. See here. For that, I will go here, display, show tables. So joint output, select joint output. In joint output, select reactions, joint reactions. So OK, so you can see the answers here. So here one is 5.25, another one is 3.25 kilonewton. Okay, so here it is F1, F2, F3. So this is F1, so this is F2, so this is your F3. So along vertical direction. Okay, thank you.